And then second period, y'all know you have an assembly tomorrow. Yep, your discipline assembly. That'll be exciting. In second period, though, so our class might be cut short if that goes over. We'll just kind of see how it goes. Okay? Okay, I'm going to write a bunch of stuff up here. I just want you to copy it down. There will probably be some symbols you do not recognize. We'll talk about those in a second. So if f of x is continuous on a to b and f of a is not equal to f of b, thank you. Then for any k between f of a and f of b. Okay, this is where all the weird symbols come in. So just kind of write them down. So one of them is like a backwards capital E. The other one's kind of like a curvy E, okay, but it's facing forward. And then the last abbreviation on that bottom line is ST. Do we know any of those?
I know the forward-facing E, the curvy one.
Okay.
Okay, never mind. I know we talked about it in Greek.
Okay, good. This is within. So you would use that symbol if you're saying that it's like on that interval. What about the ST? No? Such that or so that? Didn't y'all have that one last year? Maybe? No? Okay, so that one's within, that one's such that. The capital backwards E means there must exist. So now I'm going to read it to you again the way that you would say it, even though there's a bunch of weird symbols. So if f of x is continuous on the closed interval from a to b, and f of a is not equal to f of b, then for any k between f of a and f of b, there must exist an x equals c within the interval from a to b, such that f of c equals k. Okay, probably that sounds like a bunch of garbage. We're going to draw a picture and kind of explain it, okay? So draw an f of x for me. What has to be true about the picture we draw? It has to be what? Continuous. So we're just going to do like a little function like that. So draw a continuous function. Now, f of a and f of b cannot be what? They can't be equal. So I'm going to put my a here. I'm going to put my b over here. Now, f of a and f of b are not referring to the x values. What are they referring to? The y values. So f of a would be like here, because that's a y value. And then f of b would be like here. So remember that f of a and f of b refer to the height of the function at those points. Okay, so at this point, we're right here in the definition. So then it says, for any k between f of a and f of b. So k is going to be a height that is between that bottom f of a and that top f of b. I'm going to put my k here. That's going to be k. But notice that it says for any k. So I'm just kind of picking one. As long as it's between those, though, that would be okay for a k. Okay, so it says for any k, there has to be a c where f of c equals k. In this statement right here, C is an x value, K is a y value. So if I come over here in my graph, right here, that's my C. So what that means is that for any y value that I pick, there has to be a point on the graph with an x value that goes with that y value. Okay? Now, I'm going to give you one more example that will probably make a lot more sense than that. Okay, we're going to use height, because height is easy. So label this height. Okay, let's pretend like when you were 2 years old, you were 3 feet tall. Just pretend. So when you were 2 years old, you were 3 feet tall. Now you're 18. Now you're 18 years old, and let's just pretend to keep it easy that you're 6 feet tall. So when you were 2, you were 3 feet. Now that you're 18, you're 6 feet tall. You're, I guess, a pretty giant toddler. Okay, pick a height in the middle. 5 feet. Must there have been a day when you were 5 feet tall? Yes. Must there have been a day when you were 4 feet tall? Yes. Now, must there have been a day where you were only 1 foot tall since you were born between 2 and 18? No. Because think about it. If you were already 3 feet tall, would you have gone back down to 1 foot? No, that doesn't make sense. So what it's saying is that if you pick a y value in the middle, you must have hit that y value somewhere between the x's as well. Okay? So what I want you to do is look at your homework. We're going to do one of the word problems first, because these kind of make the most sense. Go to number 8 on the back. I want you to just read through it for me. Okay, you are reading through number 8 on the back. Okay, story time. One night in January, the outside temperature at midnight was 42 degrees Fahrenheit. Oh, is it numbered stupidly? Yeah, my bad. We're reading this one. Okay, then it says, at 10 a.m. the next morning, the temperature was 57 degrees. Now, think about temperature. Temperature, is it continuous? Can it skip temperatures and go from 80 to like 90 without hitting all the temperatures in the middle? No. So I'm going to put here, temperature is continuous. Okay, and we know that to be true because your thermometer can't skip entire numbers. It's going to have to heat up or cool down to get from 42 degrees to 57. So read through A. It says, must there have been a time between midnight and 10 a.m. when the temperature hit 50 degrees? Yes or no? Yes. How do we know that? Because where's 50 degrees? It's between 42 and 57. So you would say yes. 50 degrees is between 42 degrees and 57 degrees. Okay, so IVT would apply in that situation because the temperature that they gave us is between the midnight temperature and the 10 a.m. temperature. Okay, letter B. Must there have been a time between midnight and 10 a.m. when the temperature was 40 degrees? No. Why not? Okay, 40 degrees isn't between 42 degrees and 57 degrees. Okay, now let's get technical here. Letter C. Could there have been a time where the temperature hit 40? Yes. Is it possible? Sure. But does this theorem guarantee it happened? No. So you would say yes, it's possible. So this theorem isn't going to tell you that it can't hit any other numbers. It's just going to say that it has to hit the numbers between those endpoints. But that doesn't mean it doesn't ever go outside of them. It just means it has to hit the numbers between them. Okay? All right, we are going to break this down into steps, just like we did last week. So, steps for IVT. steps for IVT. The first thing that you have to check is that your function has to be what? Starts with a C.
Continuous.
Okay, f is continuous on A to B. Now, for most functions that we're going to do today, that's going to be true. They're going to be x squared, x cubed, functions that are all pretty normal. Okay, step number 2. F of A and f of B cannot be what? Cannot be equal to each other. So your y values cannot be equal. That's the second thing. Now, the third thing is that the k value that I want has to be where? Between them. Very good. So I'm going to put my k value is between f of A and f of B. So the k value is between f of A and f of B. Then I'm going to write the conclusion again. I want you to write it because you have to get used to all those symbols. So, therefore, there must exist an x equals c within A to B such that f of c equals k. So there has to be a c between A to B so that f of c equals k. Now, if they ever ask you to find c, you are going to set f of x equal, this should be an x, sorry. Pretend like that's an x. Set f of x equal to k.
Wait, what should be an
And solve this little weird this right there. That's an x. Okay? So if it asks you to find c, you're going to set it equal to the number that you want and solve. A lot of times you don't have to do that, sometimes you do. So we're going to put it on there as kind of like an additional step. Okay? All right, turn the page. We're going to look at our first example. Everybody good? All right. First example, number 1, is going to be for f of x equals x cubed. Does intermediate value theorem guarantee, and I'm going to abbreviate that IVT. Does IVT guarantee that f of x has a root on negative 2 to 2? If yes, find the c. Does IVT guarantee that f has a root on negative 2 to 2? If yes, find the c. Okay, so first question, root. That's an Algebra 1, Algebra 2 word. What does that refer to on a graph if you are finding the roots? Okay, very good. Root is going to be the x-intercept. And then I thought I heard somebody say it's the 0. That is true. Okay, the words 0 and x-intercept are the same as a root. So if I want my graph to be at the x-intercept, that means that my y has to equal 0. Because I'd be on that axis, yeah? Okay, so step 1. What does my graph have to be? Continuous. Think about x cubed. What shape is it? Just goes like this, right? So is it continuous? Yes. So I'm going to put f is continuous. Okay, for all real numbers. Now, where does it have to be continuous? Only from negative 2 to 2. But if it's x cubed, that's continuous everywhere. Okay? Step number 2, what can't be the same? F of A and F of B. Now what's our A and our B here? Okay, good. So I need to find F of negative 2. I need to find F of 2. And then I need to see if they're equal to each other or not. Which one do I want? Not equal. Plug in negative 2. What is negative 2 if I cube it? Negative 8. Because I do negative 2 times negative 2 is 4. Times by one more negative 2, we get our negative 8. What about F of 2? Okay, are they the same? Good, and we want that. Okay, step 3. So they were not the same. If I want a root, what y value do I want? Is 0 between those? Between negative 8 and 8? Yes. So then you would say 0 is between F of negative 2 and F of 2. So then all 3 of our conditions were met. Then we're going to do our little conclusion statement. So we would do ... There must exist an x equals c within, what's our interval? We don't want to put a to b. We want to be specific. Negative 2 to 2. So that, what is the y value going to equal? 0. So there has to be a c where f of c is equal to 0. Now let's say we had to find it. So put find c. We're going to let our equation equal the number that we want. So I'm going to let f of x equal k. Well, what is f of x? What's our general equation? What was f of x? X cubed. And what's our k that we want? 0. Now, if you know your parent functions, okay, when does x cubed equal 0? At 0. But pretend you didn't know that. How do you get rid of a cubed on a graph? You cube root it. Very good. So I'd cubic root here. I'd cubic root my 0. But then what's the cubic root of 0? 0. Now, can I also point out to you, is 0 on this interval that we said it's supposed to be on? Yes, that has to happen too. Okay? But it is, so we're fine. All right, example number 2. Our function is going to be f of x equals x squared plus 4x. Question is, does IVT guarantee f of x equals 3 on negative 4 to 0? If yes, find c. So x squared plus 4x, we want to know, does it have to equal 3 on negative 4 to 0? What's step number 1? Okay, we have to check if it's continuous. Think about the shape. What shape is x squared plus 4x? Our parabola is continuous? Yes. So f is continuous. Now, you could say for all real numbers, but where does it only have to be continuous? On negative 4 to 0. Oops, make these closed. Sorry. Okay, but is it also continuous for all real numbers? Sure. So in that case, you could put either one. Doesn't matter. Okay, step 2, what do I have to find? Okay, what is f of a and f of b here? F of negative 4 and f of 0. So find both of those for me. And what does the relationship between them have to be? They cannot be what? Equal. So we're plugging into f. F is right here. So I want negative 4 squared plus 4 times negative 4. What's negative 4 if I square it? Positive 16. Then what's 4 times negative 4? Negative 16. What's 16 minus 16? 0. Now we're plugging in 0. So I would have 0 squared plus 4 times 0. What do we get for our second y value? Okay, we go on to part 3 or no? No. What are f of a and f of b not allowed to be equal to? Each other, right? So if that's the case, then you would say, therefore, we don't even move on to step 3. IVT does not apply because f of negative 4 was equal to f of 0. And that was not supposed to happen. They're not allowed to be equal. Okay, now before we go on to the next example, I want you to think about why that matters. Why do you think that matters? Yes. Okay, think about, if they're the same, how can k be in the middle of them? Right? That doesn't make sense. If they come out the same, no number can be between them. So that's why step 2 matters, is that they can't be equal or nothing will be between them. Alright, next one. Number 3, your function is going to be x squared plus 1. And the question is going to be, does IVT, guarantee that f of x equals 5 on the interval from 0 to 3? If yes, find C. Bless you. Okay, step number 1, f has to be what? Okay, x squared plus 1 is a parabola. Is it going to be continuous? Okay, so f is continuous. And then remember that I have choices here. I can just put from 0 to 3, because technically that's the only part that it really has to be continuous for. But I can also put all real numbers, because it's a parabola. Okay, step number 2, what are we finding? Yep, f of 0 would be f of a. And what would my f of b be? F of 3. Okay, find both of those for me. And then I want you to write out your step 3. Look back at your notes if you need to, then write out your conclusion too. Okay, so this one should be open, and then when you're saying continuous, it should be closed. So in the question, it'll usually be open, and then in your continuous part, it should be closed. Okay, what's f of 0? What should go here? 0 squared plus 1 is 1. What should come here? 10. What should your third step be? What number has to be between them? F of x needs to be equal to 5. Is 5 between 1 and 10? Yes, then you should be able to go on to your conclusion statement. So I have a 1 here, a 10 here. Then I would have 5 is between them. Therefore, what comes first? There must exist x equals c within what interval? 0 to 3, so that what? F of c gives me the number I wanted, which was a height of 5. Now, if I want to find it, I just set my function equal to that number and try to solve. So what is our function here? Okay, so I'm going to set x squared plus 1. Find c. X squared plus 1, what do I set it equal to? What's the number I want? 5. What would I do first? Okay, take away 1. 5 minus 1 gives us what? Okay, 4, and then my next step, that's going to come up. What would I do to get there? When you take the square root on both sides, that does introduce a plus minus, so it would be plus or minus 2. Now question, when we put x equal to c, where did it have to be within? 0 to 3. So can I allow for both of those answers? No. I would say only 2. Negative 2 gets crossed out because it is not between 0 and 3. So I'm going to put a little star here. I'm going to put negative 2 does not count because it's not on 0 to 3. And that's just kind of a side note in case you go back and, try to do an example or something with it. So negative 2 doesn't count because it's not between 0 and 3. Alright, next one. F of x equals square root x minus 4. Question is, does IVT guarantee f of x equals 2? On 5 to 13. If yes, find C. Okay, step number 1, what has to be true about f of x? Okay, continuous. Now, square root is not continuous for all real numbers. Okay, square root usually starts at 0, and then it kind of like boings off to the side. Okay, so if it's x minus 4, which way does that shift my parent graph? To the right, okay? So 1, 2, 3, 4, and then it's going to go like that. What did you say? Yes. Remember though, it only has to be continuous where we want it to be continuous. So if I'm really mainly looking from 5 to 13, well this is 4, so from 5 to 13, is my graph going to be okay? Yes. So I would put f is continuous on 5 to 13. And those should be closed.
Will we ever have open ones?
The open ones go in the ... right here. See how this one where you put within, this one should be open, this one should always be closed. Okay? Step number 2, what do I have to find? So let's get rid of A and B. Let's use this problem, f of 5 and f of 13. So find both of those for me. So f of 5 would be the square root of 5 minus 4. What's 5 minus 4? What's the square root of 1? Okay, let's talk about that. So the question that I have for you is, if the square root is already there, should you put a plus or minus on it? No, the only time that the plus or minus comes in is if you square rooted both sides. So if the square root was already there, you don't add a plus or minus to it. But if it started off as x squared and you're solving, that's where that plus minus comes in. Okay? Now let's do our 13. 13 minus 4, what do we get? Square root of 9 is 3. What's the number that we want? F of x to equal 2. Is it between them? Yes. 2 is between f of 5 and f of 3. Oh, said that wrong. Thank you. So then what would my conclusion be? ... Write it out for me, and then I want you to try to find it. So we're not doing super difficult solving here. This is just to kind of remind us of how to solve square roots. Okay, to find C, I kind of ran out of room, so I'm going to write over here. What do I set equal to what? Okay, the function square root x minus 4 equal to the number that I want, which was 2. How do we solve? Okay, good. Some people will say, oh, add the 4. Can't do it if it's inside. You have to get rid of the square root first. What is 2 squared on the opposite side? Okay, so I have x minus 4 equals 4. Then add 4 on both sides. What is x going to be? 8. Now question.
Yeah, it is. I'm going to get it later.
If x is 8, is that between 5 and 13?
Yes.
Good. Okay, next one. I think we have like maybe 2 more left. 2 more left. Did you say he has a fat?
No, I
Morris. Sean, you better not be talking nasty over there. Okay? I want to hear that. You could say he has a fat brain full of knowledge. Get you on that. Because that's what we're really looking for, right? It's a big brain. Why are y'all saying, oh no, this is great? Okay, we're going to get to review some stuff.
Oh my god. I just looked up.
Negative pi till 3. Oops, open. This is a pi. Just to make you remember it. You're welcome. Okay, you're welcome. Okay, the first thing we have to check is what? If it's continuous. Now, is this just an easy, oh yeah, it's continuous. No, we're going to have to go back and use our limit stuff from last week. So, think about continuous. We're going to have to break step 1 down. I'm going to put continuous and then a question mark, and we're going to do our 3 pieces from last week. What is the first thing that we check? Okay, that's the second step. Step 1, you just have to plug it in where it goes. F of 0, because that's my break point. Okay, yeah, that's okay. So, where do I plug in, top or bottom? Where does it include 0? Equal to is down here, so I'm going to do e to the 0. What's that? 1. Step number 2, I have to check the left and the right limits, which means I'm not only going to plug 0 on the bottom, I'm going to have to go back and plug it in on top. So for step number 2, limit as x approaches 0 from the left, and the limit as x approaches 0 on the right. Now I'm going to go ahead and copy down 1 for the right limit, because I already did that, right? We already plugged into the bottom, so this one's done. Okay, what is the sign of 0 plus 1? Okay, so 0 is your pinky, sign's on bottom. So there's nothing down there. So what's the sign of 0? 0 plus 1 is 1. So overall, did our limits come out the same? Did they also come out the same to step 1? Yes. So the limit as x approaches 0 for f of x is equal to f of 0. So I should have put the little numbers on here. So this is I, this is I, and then this is I. Yeah? Okay, so 1, 2, 3. Step number 1, you check the y value. Step number 2, you check the limits. Step number 3, you make sure that they're the same. Now remember, this 0 down here shouldn't have a plus or a minus on it, because you wouldn't have gotten there if the plus and the minus weren't equal to each other, right? Okay, great. So we did big step 1. Is it continuous? Yes. Okay, step number 2. What do I have to check? F of A and F of B. What are my A and my B here? Negative pi and 3. So, yep. Oh, you weren't here when we did this. You and Mr. U still. All of this crap from here to here is what you and me still have to go over. But that's how you break down if you know it's continuous or not. And I'll go over that with you. But then you would, okay, that's a good question. Fontenot, I can't think of your first name. Is it Camille? Okay, yes. Camille said, what about if these weren't equal? Would you keep going? No, you say it's not continuous, IVT doesn't apply. But it was equal, so sad day, we have to keep going. Okay, so we are finding f of negative pi and f of 3. What are these not allowed to be to each other? Equal. Let's do f of 3 first because it's easy. Where do I plug in f of 3? Less than 0 or greater than 0? Okay, so that'd be e to the 3. We're just going to leave it alone. Good enough. Okay, now let's do f of negative pi. So I would need to find the sine of negative pi, and then I'm going to add 1.
So that'll be 1.
It is going to be 1. Because what's the sine of pi usually?
0.
0. Negative pi just means you went around the circle the other direction. Okay, so if I do negative pi, that's still here. So I would still be on my pinky, I would still have no fingers underneath, so it would still be 0 plus 1, which is 1. Were they equal to each other? No. Step number 3. What's the number that has to be in the middle? What do I want f of x to have to equal? 4. Now, let's do some approximating here. What is e by itself about? Okay, make it easy. 2. What's 2 cubed?
8.
8. So if this is bigger than 8, and that's 1, is 4 between them? Yes. So I'm going to put right here 8-ish. Okay? Pretend. 2 cubed is 8, then e cubed is 8-ish, but it's even bigger than that. So we would say 4 is between f of negative pi and f of 3. So it was continuous. My y values weren't the same. 4 is between them. Therefore, there must exist an x equals c within the interval from negative pi to 3 so that f of c is 4.
So every time that like you're changing
The interval and the number you wanted. Don't turn the page. What do we have to find? I know, but I'm going to add it at the end. Okay, let's say that we want to find c. What do we want our function to be equal to? 4. So, let sine x plus 1 equal 4. And then we're going to let e to the x equal 4. Okay, now question. Sine goes like this, yeah? What's the biggest that it ever gets? 1, then negative 1, then 1, then negative 1. What does the plus 1 do? Moves it. So instead of only going to 1, how high does it go? 2. Does it ever get to 4? No, so no solutions. Okay, if you just think about the graph, that doesn't make sense. Sine never gets bigger than 1. If you add 1 to it, it never gets bigger than 2. So 4 is not ever going to happen. Let's do this one. How do we solve? Yes, you do. It's very natural. Natural log. Okay, you're going to ln both sides, yeah? So how do you cancel out an e? You're going to ln here, ln here. And then what happens with ln and e? They cancel out. So x would be ln 4. And remember, ln 4 is just a normal number. Okay, it's a decimal. We don't know what it is, but ln 4 will work. Okay? All right. I want to make sure we do part of number 1 on your homework. So we do have one more example, but go look at your homework, and I just want you to start number 1. So it has a part A, a part B, and a part C. Okay, A, B, C on number 1. Yes.
Do all 3?
Yeah, go ahead and do all 3. So you're looking at number 1, A, B, C. Are you going to have to break down part A, yes or no? Yes, because what happens at negative 2?
well, it's piecewise.
It's piecewise, and that's the break point. So you're going to have to be specific in how you say it's not continuous. And this is supposed to be closed. What'd you say?
You want to know what? Oh, water.
No, don't do that. I mean, you can, but you don't have to. Okay, so what would I put first?
No, because
Okay, your answer is going to be no, but let's use the definition. What's step 1 in the definition? Okay, I need to find f of negative 2. Would I be looking at the open dot or the closed dot? Where's the closed dot? Negative 2. What is the second step? Okay, very good. I want the limit as x approaches negative 2 from the left of f of x. And then I want the limit as x approaches negative 2 from the right of f of x. Now, looking at the graph, remember, you just cover it half at a time. So if I want to do the left limit, I'm going to cover this side. Where does it look like it's going to? What height? 1. What about the other side? Negative 2. Were those the same? No. Then what do we say? Therefore, not continuous. Because remember, those have to be, and actually let's put not continuous at negative 2. Is it continuous everywhere else on the graph? Sure, but at that one point, it's not. Okay, now go down to letter B. Does IVT guarantee that f of x equals 0 between negative 5 and 2? What's step 1? Has to be continuous. Where is it not continuous? From negative 2 to 5. So if I cover on my thing from negative 5 to 2, that'd be here to here. Is it continuous between my hands? Then does IVT apply? No, and you're done right off the bat. So you'd say f is not continuous at x equals negative 2. And remember, the reason that matters is because negative 2 is on your interval. If we weren't looking at the part with the break, it would be okay. So therefore, IVT does not apply. If you would like to use DNA as an abbreviation for does not apply, that's fine. Okay, now go to letter C. From negative 2 to 5, I'm going to use my hands to cover the graph. From negative 2 to 5. Is our graph continuous on that interval? Yes. So is it going to work on that one? Yeah, what do I want f of x to equal? 0. And if you look at your graph, where does my graph start? How low? Negative 2. How high does it end? At 5. 3. Is 0 between those? Yes. Then you would be going through and just stating those, but using the graph instead of plugging it in yourself. So step number 1, you would say f is continuous on negative 2 to 5. Step number 2, I'd find f of negative 2 and f of 5. And then step number 3, I would state if the number that I want is between those. So what is f of negative 2, we said? Negative 2. What is f of 5, we said? 3. What's the number that I want? Is it between them? 0 is...
Oh, yeah, well, I'm sure.
And then what would our therefore be? Does it guarantee it? Therefore, I'm just going to put yes. Okay. Alright. Unless it tells you to find C, and it doesn't in this case. But if it did tell you to find C, where did it hit 0? At 1. And you just have to use your graph. Okay? We're going to finish one more example next time. Oh, but I do see all. Yes, great. So we're going to do one more example on this next time. Yes?
You don't have to write the entire therefore.
That's a good question. Listen, guys, your homework is mostly graded completion. So as many times as you need to write, therefore, there exists, blah, 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 that's for you to practice. So if you know you're going to do it right after 3 times, you don't have to write it out every single time. Okay, that's going to be up to you based on how much you think you need to practice.